Welcome everyone. Hi, good morning. So kita akan buat revision for basic operation. So, the first basic operation is the adder or summing junction. So the summing junction tells you that the two different sequences will be summed up and produces the yn or the output. The next operation is the multiplier. So when a sequence goes into a multiplier, it will multiply with the multiplier, okay, with the constant a or whatever constant there is on the multiplier. Okay, so the next one is the product modulation. Product modulation basically is it's two sequences that is multiply with each other. Then you come to the unit delay. Unit delay is when a sequence is delayed by one sample. So if the sequence goes through several delays, then you have to count how many delays that will is the number of delays is dependent on the number of unit delays. So if let's say the sequence goes through into 4 unit delays, that means xn minus 4. Okay, and then for the time reversal folding operation, so this is where the sequence is mirrored on at n equals to 0. So when all the right side of the sequence goes to the left side and the left side goes to the right side. And then the last one is the branching operation. It is used to provide multiple copies of a sequence. So when a sequence goes into a branch or goes into a node, it will make copies of itself. Okay, so this particular operation looks very simple, and this is the operation that most students will make careless mistake of. So normally, what I see, students will treat this branching node as a summing junction, which is not correct. Yeah, dia tak betul. It's not a summing junction. It's a branching operation that makes copies of the sequence. So it looks simple, but please be mindful when you see this particular operation. Okay, so let's go into some examples. Okay, we start dengan example D. Okay, so we see that here yn is a product ataupun is a summation of all these signals. Okay, so we have 1, 2, 3 and 4. So you should have 4 terms here because ni semua summation, junction ataupun adder. Alright, so let's just look. How should I write this? Okay, so let's do this. So for 1, okay, this output after H0, which is a multiplier. So we retrace the steps. Okay, it's coming from this side. Okay, so the signal that goes into H0 is a product of this summation junction or adder. Okay, so what signal that goes into this summation junction? Okay, so we trace from here. It is xn going into a branch. Okay, and the output here is xn. Okay, xn. Remember the nodes is the nodes. If a signal goes into a node, it makes copies of itself. Yeah. Okay, so this one. All right. So this is xn. Okay, xn goes into the node. It will come out here as xn. Here also is xn. Okay, right. So for 1 is the signal goes into the summation junction is xn. Okay, what's the next one? So we have to trace this. Okay, so it's going into is a delay unit, a delay unit, a delay unit until this part. So it is xn actually going into several unit delays. And how many unit delays? 1, 2, 3, 4, 5, 6, 6 unit delays. So at output 1, okay, at output 1, we have actually H0, okay, times with xn plus xn delay 6 times. Okay, so that is what we have, right? So then we look at number 2. Okay, 2, we do the same process. Okay, so H1 is a multiplier. So you see, this multiplies with H0. So this is the same as if you go back to the operations, basic operations. So you see that this multiplies with the sequence multiplies with the constant there. All right. So okay, we do repeat the same process. So H1, okay, we trace back where this is coming from, where the signal is coming from. So it is a going from a summation junction also. What goes into the summation junction? Again, we trace back to this line. So xn going into a node, it copies itself. So we have xn going into a delay. So one time delay goes into a branch and comes into the summing junction. So here you have the xn delay one time, okay, delaying one time. And then here is another signal going into the summing junction. So what is the signal? So again, we trace back to xn. Okay, xn going into 1, 2, 3, 4, 5. 5 delay unit. And so you repeat the same process for all the multiplier. So this signal multiplies with H1 and this signal multiplies with H0. So okay, this is like a very amateurish way of writing this. If you have a better way of writing this, please do so. Just want to make the idea clear to everyone. Okay, so now we go to number 3, which is H2. Okay, so again, we trace back the signal that goes into H2. It is coming from xn minus 2, okay, because of 2 delays, plus, because it's a summing junction, this signal, okay. So this is x n minus 4, right. Then you have number 4, H3, okay. So this is H3 comes from this one. Okay. So this is, there's no summing junction, it's just a branch. That means xn goes into a delay, goes into a delay, goes into a delay, and goes out to H3. So goes into H3. So this is x n minus 3. Okay. From here, you can write, okay, so yn equals to H3 x, H3 x n minus 3. So tak kisah you pakai bracket apa pun, just make sure it's consistent. H2 times x n minus 2 plus h2. Let's write like this. Okay, so let's write it like this: h2 x n minus 2 plus x n minus 4. Okay, then plus h1 x n minus 1 plus minus 5 plus h0 xn plus 6. Okay, so you can write it like that, yeah? Okay, so that is your yn. Okay, now I hope that's very clear to you. Okay, so let's look at another diagram, schematic, right? Okay, let's look at okay, so let's look at B. All right, now we have this diagram. Okay, again we look into what is yn made of. Okay, yn is made of a signal that comes from this summing junction. Okay, so again, if you look closely, this is yn, this is the a node, a branch. Okay, so this actually, okay, this is actually yn. Okay, let's make this bigger. So this is yn. Okay, this is a branch here. So this is yn, and this is also yn. Okay, again, it's a branch. It makes a copy of itself. So now, because this is yn, this is yn. So what is yn? So yn is coming from this particular summing junction. So here is very clear that this is a very clear signal. But what is this one? Okay, this is coming from this summing junction. But the definition, this summing junction is a product of the summation of the signal and the signal at this side. Okay, but this one, we don't know what the signal is, okay, because you don't have any, we just know it comes from this summing junction and goes into this summing junction. So we have to give it a name. So let's give it a name as Wn, okay, for this particular signal. So here, okay, so for yn, we can write as yn equals to, okay, at this summing junction, Wn plus, okay, plus all the signals that goes into this junction. So yn goes into the summing junction. This is negative d2 yn minus 1 because of the delay at this, yeah, at this side. And then it sums with the negative dy yn, okay, and then it goes into a delay. So here main conteng-conteng sikit. Okay, at this point, let's see, at this point, let's draw here. Okay, so we have minus d 2 y n minus 1 plus negative d1 times with yn. Okay, because this is a multiplier, so yn multiplies with negative 1, sums with this particular signal. Okay, and then all this signal is delayed by 1. All right, so at this part, okay, at this part, it is all delayed by 1. So negative d2 yn minus 2 minus d1 yn minus 1. Okay, so that is the output here, right? So the sequence here you can write as such. So yn equals to wn plus negative d2 yn minus 2 minus d1 yn minus 1. Okay, minus 1. All right, so this is your yn. Now we have to define what is wn, because the wn is what we've given to the unknown signal. Okay, so wn is a product of a summation of a sum of this particular signal and this particular signal. Okay, so this one is very clear. So xn times p naught. Okay, so this is p naught xn. All right, and then for this signal, okay, so we have to start from the bottom here. Okay, from the bottom, so xn goes into p2 and delay 1 time. So let's this one let's okay, three times. Okay, so for that part, okay, or we label it with a number, a letter or something like that. It's also possible, not a problem. So conteng saja. So this is P2 xn, because delay 1 unit delay, so this is P2 xn minus 1. Okay, and then at this summing junction, okay, at this point, this is a sum of this is xn p1. Okay, so at this point it is p1 p2 xn minus 1 plus p1 xn. All right, and then all of this, okay, goes into the unit delay. Okay, all of this goes into the unit delay. So let's this. Okay, so we have the p2 x n minus 2 p1 x n minus 1. All right, so it goes to the summing junction. So here we have, okay, for that, so wn equals to p naught xn plus, okay, p2 xn minus 2 plus plus p1 xn minus 1. So that is wn. All right, you understand? Okay, so this one, okay, substitute this equation that we get into bersama N. So then you have your YN. Okay, so the key is that you need to see the output, and then where does this signal comes from. So it's always at the summing junction. Look at the summing junction. Okay, now let's go into another example. Okay, so this is diagram A. Diagram A. Now, okay, so again we look at yn. So yn is a product of two terms, two terms. Ada dua sebutan dekat sini. So we have this one satu and this one dua. Okay, but then we have to trace back where this comes from. So this comes from this summing junction. Okay, so xn goes into a summing junction, right? And then it produces a signal that goes into P0. Now, this is not a branch, it's a summing junction, okay? So this is not xn, but this is also another signal. So let's name it as wn again. Okay, so just whatever means whatever sequence, okay? So wn, okay, for sequence that we don't know. Yeah, okay, so we write, okay, for yn again we can write here the signal wn goes into P0, okay, goes into P0 and it goes into the summing junction. So we have here, where should I write this? Okay, so yn equals to, oh sorry, P0 wn, okay, plus what? Okay, so here we look at wn goes into P2 and then it delays one time. Okay, so this one is, at this point, this is P2 wn minus 1. Okay, then it sums with wn times P1. So at this point, okay, it is P1 wn plus P2 wn minus 1. Okay, and then all of this goes into a unit delay. So when it goes into a unit delay, then it goes into the summing junction that is for the output of yn. So here we can write as we delay all of this sebutan, all these terms. So here you get P1 n minus 1 plus P2 wn minus 2. Okay, so there you have it. You have yn in dalam sebutan wn. Okay, but we want yn actually to have xn, right? So now we have to look at what is wn, so that we can write wn in terms of xn, and it can be so that we know the relationship between yn and xn. Okay, so yn yn is a product of xn plus this signal here. So wn is xn plus, what is it? So let's look here. We start from the bottom here. So wn goes into a node, another node, okay, and it copies itself here. So all this is wn. So it goes here times with negative d2. All right, so at this point, kejap arrow ke dalam, okay, whatever makes sense to you, okay? So let us be consistent. Okay, so at this point, so this is mm, D D negative D2 negative D2 Wn minus 1 because delay 1 unit. Right, so and then at this point here it is oh, at this point, never mind. Okay, so at this point habaq suruh consistent lah. Okay, so this at this point, okay, so negative D1 times Wn plus or rather minus D2 Wn minus 1. Okay, and then here delays, it is all these terms delayed by 1 unit and goes into a summing junction. So here we can have we can write as negative D1 Wn minus 1 because delay 1 time minus D2 Wn minus 2. Okay, right. So or you can write as xn minus d1 Wn minus 1 minus d2 Wn minus 2. Okay, so once you have the expression of Wn, then you are basically done. Okay, because if you substitute into this equation for yn, right, so you still have the sebutan in Wn, which is not what we want. Yeah, but basically we now see there's the relationship between yn and Wn. Okay, right, now we look at the last example. Okay, so for this example, this is example C actually. This is C. Okay, right. Now it looks complex, but not to worry. If you use the same thing the same formula that I explained to you, you will be fine. Okay, so you look first at yn. Okay, because we want to write what is yn, so you have to look at yn. So yn is the product of this signal here and this signal here. Okay, so this one, okay, we know that it has to be in two terms. Okay, so we have to write but this consists of several unknown signals also lah. Okay, so we see that yn consists of two terms. Okay, we go back, we see that this is a summing junction, so we don't know what this signal is. We go back, this is also a summing junction, and we know what this signal is. So at this point, this is a signal that is H0. This is not good. Okay, so at this point, this is H0 xn. So this is, let's write that here, H0 xn. Okay, and remember it goes into this node or branching, so it duplicates itself. So this is H0 xn, also this is H0 xn. Okay, so now we know that for this one, for this signal, is we know the name of this signal. Okay, now it goes into the summing junction and we don't know what this signal is. Okay, because it is a summation of these two signals, so we have to give it a name again. So let's try wn again. Okay, so wn goes into the summing junction, and and it goes into this summing junction. Okay, now again we don't know, it will give an output, of another signal and we don't know what that signal is also. So let's name it AN. Okay, apa-apa AN. All right. So AN goes into the summing junction, and this is also AN going into this units. All right. So you have from here, you can write the YN just as I've shown before. The most important thing is that you look at the output first, and then you retrace the signals. And for all the for signals that you are not that is coming out of a summing junction, and you don't know what the name of the signal is, or where this originates, then you just give it a name. Okay,